This one is Packet Tracer 9126 for the CCNA course number 2, one step ever closer to that ultimate goal of becoming a certified Cisco network associate. So today we're talking about NAT. What is it? How does it work? Basically, what do the packets look like when they get used through NAT translation? So it just stands for network addressing translation. So it's turns for IPv4 anyway, it turns an IPv4 private address into an IPv4 public address, and then they're kept track of with port numbers and stuff like that. But anyway, let's start getting into this packet tracer. So let's just pull up PC1, and we are going to say paste. And go to here to start our simulation mode. Say go. So that packet is now started. So what is our source address on this thing? So we're going to go 1, 2. Our source address is 10.205. And that should be that of 10.205. That's our address. And it's going to 64.100.201. Well, where's that? Is it our router? Would it be the IP address of our router? Well, no. It's not, because you'll know that it's the destination address, right? So none of our interfaces are going to have that 64.100.201 address. Now there's one there. It's 100.202. That's not it. So 100.201, who else would have that address? Well, we're going to branch server. How about them? Would they have it? Nope. So who's got this thing? Let's try the R4. Okay, so cycle down a little bit. Let's go back up. Now you'll notice right here on interface serial 001.1 that the IPv4 address is right here, 64.100.201. That's where that packet's going, because that's the public address of that private branch server right here. That's the public address. That's what the world sees. That's how the world gets to branch server. Okay, so let's cycle over here. Let's start going through here. Look at it one more time. Did anything change? Nope. 10.205, 64.100.201. Nope. Let's do it one more until it's over the R4. Okay, what does it say now? 64.100.103. What is that from? That's, of course, our source IP address got translated through that network addressing translation to the global routable address of that R2 router. And where is it going to? Well, of course, it's still going to the R4, but it's going to get pushed off, as you'll see in this packet on this out layer over here. So the source address stays the same. It's still our R2 router, but the destination just changed. See that? It used to be the router, but the router's saying, well, of course, this isn't for me. This is on port 80. It's got to be for my branch server. So it's sending it off to branch server. That's the address. 172.16.03. 172.16.03. Capture forward. Ta-da! Okay, so now we got to the destination. Let's take a look at what's going on. So the source and destination stayed the same since that coming out of R4. And the IP address for the source is now changing because it's going to turn this packet around and send it back. So what's that going on? 172.16.03 is the new source address that just got flip-flopped, and the new destination address is the address of R2 right there. So we can follow this packet back. Oh, went a different way. So let's see what happened this time. It went through that R4. So the R4, see how the destination changed again? Or I'm sorry, the source IP address changed? That's 64.100.201. That's R4. So the 172.16 private address range got translated into a public address right there. And the destination address is still, of course, the R2 router. That's the global address. That's the face of this network. Nobody else knows all these things. They don't care. They just know that this router has got an interface on it that needs to be sent traffic to. Okay, so let's keep on going. What do we got now? Okay, it's here. It is at the router. It's got to its destination. Destination IP address is 64.100.103. So we're there. Now, where's it gonna? What's the new destination? So it strips off the R2 router's destination IP address, translates it to, oh, this is going to go back to, I remember him. I was following his port number. Well, isn't that nice? He is going to his IP address of PC1, right? Yeah, PC1. Send out this request, and we're going to give that back to him. So it's that we're going to send it right back to PC1, 10.205. And guess what? He does. He routes it right back to PC1. And PC1 should have had a web page, but he doesn't. So what? Who cares? So that's the end of that. That's kind of how network addressing translation works. It changes that the IPv4 private address to a public address and then back again. It was really quite an ingenious way to conserve IP addresses. Plus, you only need one IP address for this whole network. In fact, one IP address, if you're using PAT, which is the port addressing translation, you can keep track of multiple conversations up to, with one address, you can keep track of, well, in theory, you can do 65,536 addresses, but in practice, there's only you can use about 4,000 devices, all sharing one IP address. So it was really a good idea, because if we hadn't done that, we would run out of IP addresses in about 2000, the year 2000. But we actually ended up running out of them in 2015, I believe it was. So IPv6, we're going to have to start learning how to use it. All right, so I think we went through most of that. Yeah, we went through most of that. So these two translation tables. So let's pull up R4. IPNAT. Oh, hold on. Show IPNAT translations. Okay, let's do R4. And then let's do R2. Show. Come on. IPNAT translations. So what are the similarities here? Well, there's a couple. Firstly, the inside local similarity is their private address range. Same thing for this side. The port numbers that they're using are common port numbers, like that port 80. That's pretty common. 25, that's another common one. 443, all common port numbers. So those are, I think those are pretty much it. The inside global, those are, globally addressable IP addresses. The outside local and outside global, the similarities there are they match. The outside local and outside global match. So I'm pretty sure it's just the port numbers that they're using is what they're using to the answer they're looking for there. But can never be too sure until you get your grade. Did any private addresses cross the internet? Well, we watched that happen, and no, nothing did. None of the private ones made it. They all got translated. So let's go up to that WRS router right up here, and we are going to it says we want to filter central server. So let's just do a little copy paste job there. So home desktop, we're going to go like this, paste, go. All right, they're off to the races, and there you guys, HTTP is in the lead. So we've got this packet that just got created. Let's go one forward, right there. Okay, so what's the source IP address? Is 192.168.0.101. So that would be that of the home desktop. The destination IP address is 64.100.102. So where is that? Let's see here. Right over here. Right over there. Okay. So let's see what happens if let's see, 64.100.102. So that is actually this guy right here, because we're using NAT. So I'll just scroll back up to that one address. So the 64.100.102 right there. So that's a serial 000 interface of R2. So let's see what happens as we go through. So the source address should have changed. It's out of modem. We're not going to see it there. Should see it at the R there. No. And are we going to see it here? Yes. Okay. So the network BNAT kicked into play. So the 64.100.4.223.2. That, of course, is the globally routable address of the WRS router, or actually probably the modem. No, not going to be able to see. So that router. And then the destination address is still that of the R2. So let's keep going. See what happens here. It finally got there. 64, the source stayed the same. The 64.100.102 stayed the same on the in layer. What's going to happen when it goes out? So the source address is still that of that WRS router. And the destination IP address just did change. So it's 10.10.10.2. Let's keep on the going. 10.10.10.2 right there. That's where she's going. Forward that packet out the proper interface, and bam, it just got there. So now we're going to see it go backwards. Basically, you could just follow those breadcrumbs right back. So it came from this address, went to here. Now it's going to change those two around. So the destination now becomes the source, and it sends it back off to that WRS router. Capture forward, capture forward. Oh, it kind of went a different way there that time. So now we're here. So the destination address is 64.100.4.223.2, and we've arrived. What's going to happen when we get out? The 64.100.102 is that source address of R2, because this is the actual source, that's the central server, but of course it got translated through the R2 interface out onto the wild west of the internet. And so it had to give it that IP address. So now it's going to go back over to the home desktop. Oops, wrong button. And it arrived. How about that? Yay, look, we got a website. Sweet. So yeah, you can kind of just play around with it, kind of try to understand it. I hope I made somewhat sense of what was going on. If not, please comment below. All of these ramblings of mine, I don't know what effect they're having. So please just give me some comment, give me some love. Please subscribe. We're always coming out with new videos for your guys' benefit. Well, you guys have a great day. Peace.